All right, let's go ahead and try, in this case, 51. 49? All right, we'll do 49. Yeah, I am. I'm recording today's lesson. 49? Okay. I'm going to explain this. This will be like the 15th different way I've explained this problem, so I'm going to try this. Those are the x's and these are the y's, okay? Domain, range. This little line says if x is less than -2, that means at -2, x has an open circle. If I put -2 in the equation, that means 3 for the y's also has an open circle. Okay? If x is -2, y is 3, that'd be an open circle. When you go to map the two together, you go back 2, up 3, and make an open circle. Right here, this is a fancy way of saying -2 less than or equal to x less than or equal to 2. It has the absolute value there. That gives you two closed circles with the x coordinates of -2 and 2. What are the y values if x is -2? What do you put in the equation? You put -2 in the equation, what do you get? 3. So -2. So there's a closed circle at -2, 3. And if you put 2 in, what do you get? -1. So there's another closed circle at -2, 1. So I come over here, -2, 3, closed circle. So if you have a closed and an open together, it's going to be a closed as a result, right? And then you have -2, 1 with another closed circle. All right. Oh, sorry, back the other way. Will this work? Yeah, nice. -2, +2. Sorry, +2, -1. There we go. +2, -1. Closed circle. All right. Then finally, what does this tell you? Open or closed circle? Open at what point? 2, -3. I put it in, y is -3. 2, -3, and 2, 3. There we go. Now, you got to fill in the graph. Well, this 3, the equation, what's the line look like if y equals 3? It's a straight line, right? Well, that means for everything on the left side of this open circle, it's going to be a straight line at 3. What kind of lines connecting the dots that are both closed? It's just a straight line, isn't it? Has negative slope, should go through 1, which it will. And there you go. It connects. That's because this is a line that goes downhill. And this one, another horizontal line. And it's going which way? To the right. There you go. I like that. That requires a lot of thought. A lot of skill. That question will be on your exam, a piecewise function. Okay. All right. Somebody had a question over what? 53? We did too. Oh, it's fine. No, I told you I'd do 53. Look, if you want to make a picture of 53, I said, what was the first thing I said? Yeah.
You said that.
Yeah, I did.
That kind of makes me want to do that.
Yeah. Those brackets mean the greatest integer function. What that means to you is, if I do it like A, if I have x and y, okay? If I put in 0, for x, negative 3 is bigger than what integer immediately to the left? What integer is immediately to the left? Negative 4. So if I put 0 in for x, I'll get out negative 4. See how that works? If I put in 0.5 for x, what is 0.5 minus 3? Negative 2.5. Negative 2.5 is bigger than what integer immediately to the left? Negative 3. No, immediately to the left. Oh, because this is negative 4 right here. Negative 4 is immediately to the left. Remember, the smallest number's on the left, the biggest number's on the right. What if I put in 0.9 for this? What's 0.9 minus 3? Negative 2.1. And that is bigger than what integer immediately to the left? Negative 3. An integer doesn't have a decimal. Oh, what if I put in 1? What's 1 minus 3? Negative 2. That's bigger than what integer immediately to the left? Negative 3. That is the greatest integer function. The value you get out is greater than what integer immediately to the left. So you can see there's a lot of numbers going to have negative 3 for their y value, right? There's going to be a lot of numbers that have negative 2. So when I go to graph it out, I put in y equals math num int. That stands for the double bracket. Inside the double bracket is x minus 3. Close it off. Ready? Y equals greatest integer of x minus 3. So if I go to the graph, I go to second, calculate value, 0.5. What should it equal? Woohoo! Negative 3. Yeah. On some graphs it will connect, on some graphs it won't. You have to know it's not supposed to be connected though. All right? Oh, I got it. How can I widen the graph? How can I stretch it horizontally? Do you multiply inside the function or outside the function? Outside stretches it vertically. Inside does it horizontally. So I'm going to make each step bigger by a factor of 3. Second, I like bigger steps.
Yeah, mine's still going down.
1 divide, well, fix it.
It looks just like yours.
Fix it. No, it doesn't. See, I widened it by 3. What happens if I want to flip it? How do I do that? Put a negative where? Negative outside. Second insert negative. I flipped it. What if I want to stretch it vertically? In other words, I want a bigger gap between the steps. I want a gap 3 times bigger between the steps. Yeah, multiply the outside by what? 3. Second insert 3. Graph. See, I got a bigger step now. Yeah. All right, anything else? Oh, that's greatest integer function. Did you ever get it fixed?
No.
No. I put a 3 in front because I wanted to widen it by 3.
I widened it.
You
I knew nothing.
have to put minus 3, not x 3 times a negative x.
Oh, okay.
The little nub is a negative. The long bar is a minus. So back to the beginning. Flips it. Yeah. So that is the greatest integer function. You can graph them all out if you like, but that's about it. But that's always a good graph to go over how you can affect the behavior. By the way, that's probably your first and cheapest class in graphic design. If you'll make something, all you're doing is changing the parameters of something basic. Make it wider, make it smaller, make it colorful. You can do that. There's a code for everything. The RGB colors all had codes on the computer. You change them. Okay? Yeah, it's a lot of fun. Any other questions on the homework? None? Yeah.
63.
Well, I don't know. Is it hard?
Oh, God. You plug something in there?
63. Oh! So, find the domain and range for each function. Oh, the original domain, let's do A first. All right, so for A. The original domain was -2 to 6, and the range was what? -4 to 8. The function value of 2 equaled 8, and the function value of 6 equals -4. So what happens if you put a negative out in front? What changes, the x's or the y's? What are the y's? What happened to them? They flip over the x-axis, right? So any y that was originally negative becomes positive. So this is going to go from -8 to 4 now, isn't it? Because if I have a positive 8 for my y value, and I flip it over the x-axis, it's going to turn out to be what? -8. It has to go in numerical order, smallest to biggest. And what's the 2 do? Does that multiply the x or the y? So, now that I multiply it, should go from -16 to 8. You're stretching it vertically by a factor of 2. Nice. We don't have to do anything with the points, do we? It says find the domain and range for each function. Okay. How's that look? Pretty good? So for, I don't know, you want to do C? The domain. -2 is 6 of the original function, and the range -4 to 8. So if I subtract 3, which way is the graph going to move? How far? So all my x values are going to move to the right 3. So my new domain would be 1 to 9, correct? And then what would be my range? Yeah, the range is it's going to move everything up 1. So the range is going to be from -3 to 9. Nice. Oh, what's a negative x do inside the equation? Flips it over which? Y-axis. So, normally I had a domain of -2 to 6. My new domain would be from -6 to 2, wouldn't it? The range would stay the same thing. Excellent. I think we're getting the hang of this. Remember, Tuesday, November 2nd. Important date. All right. Any other questions on the homework? Let's get, what are we doing today? I'm going to ask you some more questions on the homework. Like 65. We know how to do like 65 and 66, don't we? What? Let's do 66. It's like one we did already, isn't it? It says find a piecewise function. You know what a piecewise function is? Yeah, it's got one of those things. Oh, my variable. What do you want the variable to be? X? All right. So there it is, my piecewise function, t of x. It said t is a capital letter. Specifies the total tax on property valued at x dollars. It says a certain state taxes the first $500,000 at a rate of 1%. All the value over 500,000 is taxed at a rate of 1.25%. Now let me ask a question. You can't have negative property value in this textbook, I don't think. So that means all my x's, there's two situations. From 0 to 500,000, right? And everything past 500,000, right? Those are the two things with the x's. So, there we go. Now here comes a judgment call. Anything up to 500,000, how do you find 1% of it? How do you find 1% of, multiply by 0.01. 500,000 times 0.01. If x is between 0 and 500,000. Oh, I got the attention of one person that has been with us for like the last 2 minutes. They kind of looked up, they looked back down. Nice. I should ask that person a question now, but I think I'll wait until we get to something better. Yeah. What about this one? Do you think at $600,000 you're taxed at a rate of 1.25%? Anything over 500,000 is taxed at a rate of 1.25%. So at 600,000, how much is taxed at 1.25%? $100,000. Anything over is taxed at a different rate. So for the first $500,000, you're paying 1%. Right? And added to that would be the 100,000 at 1.25%. Added to that, oh, how do you write that? How'd you get 100,000? No, I didn't say it. What was the value of the home? 600,000, and we subtracted what? We subtracted 500,000 and multiplied it by what? 0.0125. That's if x is bigger than 500,000. That's a hard question, especially the first time you see it. So there's two different rules. One for the haves, one for the have-nots. Nice. That's all you have to do is come up with that function. It is. You should see some different tax rates. Well, people do them themselves. I'm on a township. I'm a trustee, not a supervisor, not a commissioner. But we have to come up with ways of figuring out different tax rates also. It can be some long meetings. I like that question. That's a good question. You ready for another good question? This is fun. You'll like this. We're going to use a calculator. You don't even have to think. And we're going to use it right now. I know, I'm excited. This is for Daniel's birthday. Just think, 10 years from now, I'm still using this. It'll be on there. Daniel who? You know, the guy, struck it rich because he knew who Big Time Rush was. Easy. I didn't ask. Do you like to solve for positive or negative numbers? Positive. You got to remember that. When you put something on a graph, you're looking for when y is positive. So, y is positive. On number 70, I'm going to do 70 because you're going to do 63 for homework. To get everything positive, I'm going to take it which way, left or right? Left. Thanks, I want greater than 0. See, on 69, I take everything to the right. Okay, good. So I'm taking everything to the left. 0.63x squared minus 2.2 plus 0.3x minus 2 greater than 0. You know what? I didn't even feel like thinking. I didn't even combine the like terms. I just wrote it as is. Now remember, when you're typing this out, the little nubbin is a negative and the long one is a subtraction bar. Make sure you know which is which. I'm going to type it out. All right. 0.63x squared. Y equals, clear, 0.63x squared minus 2.2 plus, where's the absolute value at? Math and number. Very good. Absolute value of 0.3x, close it off, minus 2. What about the greater than 0? We're looking on the graph for the positive region. I think you'll be able to see it. What window do I usually go to first? Zoom standard. Okay? You could have done this on every single inequality problem I gave you a chapter ago. Why didn't I tell you? Because you need to know how to solve them. Now we can use that information to look at this, which is the positive region. Yeah, here's the positive region. This region down here is negative. This region over here is positive. See how I look at factors? And look how I look at regions. I still do the same thing on graphs. I look at regions. On the number line, would this x make y equal 0 right here on this x-axis? Yes, it would. And can y equal 0 in this problem? No, it just says greater than 0. So that would be an open circle with an arrow going this way. Do you see how the number line from the last chapter correlates with this number line I'm looking at on the graph? The positive region is also for everything this way. I don't have to pick test points. It's already picked for me. All those test points are picked. I like that a lot. Now it comes down to how can I find those numbers? Do you know how to find them? I can be not practicing. Oh, hurt. All right, we're going to find those numbers now. Second, calculate. On my calculator, 0. On some other calculators, it might be root. Okay? Root 0, maybe x-intercept. I don't know. Maybe I'm going to go 0. And it wants to know, give me an x value to the left of where it's crossing the axis at. So if I'm looking for the one that's negative, I'll go from negative 8 on the left to 0 on the right. I'm just typing in the numbers. And then my guess is negative 4. Booyah! So I know that number on the left now is negative 2.354848. I put the number in between them. Any number between your guess. I'm going to Google the next one for you. Okay? I'm going to Google it.
So,
Yeah, this is pretty cool. Watch this. Yeah.
the way you told me to, what do you do? That's what I'm right about now.
Left bound. You're not even close to where I told you to do. What window are you supposed to be in?
I hit second count.
Zoom 6. Now you're in my window.
All right.
Then you do second calc 0.
Yeah, I did that.
Give me a number to the left of that. Negative 6. Good. Number to the right of it, I picked 0. Okay? Some kid calls this Googling it. I'm going to look for the other one now, right? This kid is kind of lazy. Second, calculate 0. Oh, yeah, I'll go negative 10 to 10. My guess is 2. There you go, 2.35. No thought required. I said, kid, that works because your function's continuous. If it wasn't continuous, you'd be out of luck. He goes, I'm not out of luck because I just got the answer. I said, okay, fine, you got the answer. So, those are my 2 x values. Do I want my region going out, my region coming together? I want the region going out, don't I? Do you remember what this symbol is referred to as in interval notation? Negative infinity to negative 2.35 union 2.35 to infinity. I like that. That's not a bad one to end on, that infinity symbol. Did you get it?
Yeah.
Good. Nice. Did you get it? Good. Aren't you happy? Good. I am too. Anything else on that one? So how do you know when to use your calculator? Well, there's a little calculator icon right there. Your algebra can't let you solve a quadratic and an absolute value together. In calculus, they're always trying to solve algebraic functions with trig functions. It's hard. Well, so you use a calculator and use a 0 command to find it. Lots of ways to find the answer. I take everything to one side, look for the positive region. Okay? Let's move on. There's more to learn. I know I'm excited. Very excited. All righty. Do we need to do another one, or do you think you got the idea?
Another one hurt.
No one wouldn't hurt? Let's try number 72. What's wrong, Veronica? 72? I am. 72. You do this one on your own. I'll walk around, and whatever Daniel gets will be the right answer. Actually, I'll type it out first, just to clarify the picture. Y equals. Are you going left or right? Positive or negatives? Let's get on the same page with that.
Right.
Positive numbers we're looking for? So we want it greater than 0. Okay. Y equals 0.12x squared minus 0.3 minus the absolute value of the square root of 16 minus x squared minus, the x squared is the last thing in the square root, minus 3. I have to change my window, huh? Well, I think I'd change the window if I were you. Yeah, I'm going to change my window to negative 5 to 5, negative 3 to 3. I like that. Looks like Alice in Wonderland. The cat. It does too. Who said it didn't? Oh, yeah. That's a nubbin. You need a minus 3. Did you get it?
Yeah, I messed up my graph really bad though. I tried to do that.
Yeah, I got it. Okay. Keaton come see.
Maybe I'm wrong.
Wait a second, mine doesn't look like yours. It's not as pointy. Mine isn't either. I think it might be this rash. Yeah.
How do you know when to change the window?
Well, I just changed it because
Yeah. It's your window. Is your window the same? I'm trying to figure out what's going on.
Because you had your A plus BI on. I took that off. Okay? If you have lines, if you have whiskers out here, you have your A plus BI on, you need to turn it off. Those are only real numbers. Okay? You go back to mode and go back to real. So, what region are we looking for? Positive. So I'm looking for here to here and here to there. Anybody find the values yet? Go ahead and find the values. That's 0. Second calculate 0. So on mine, I go from -4 to -2 and a guess of -3. Yeah. Something in between it. Huh? At -4? All right, so try -3.9. No, that gets you close, but not quite. Huh? Well, you need to put a number into the left of this. This is -1. This is -2. This is -3. This is -4. Right bound, which one are you looking for? You got to make a decision. There's 4 of them.
Is it 2.24?
Yeah, I'd go with that. If you're looking for this one, you're looking for where it crosses the x-axis. So you have to make a decision. There's 4 of them. Which one are you going to choose first? If I choose this one first, I go -3.9 on the left. I go -3 on the right, and -3.5 is my guess. No, my window is right here. In left bound, right bound, and guess under second calculate 0. It says error on the bounds. Second calculate 0. Left bound -3.9. Right bound I said -3. And guess of -3.5. Onward. Yeah. Oh. Well, if I'm looking for, I'll look for this one next. A number on the left of it would be -3. A number on the right of it would be -1. And my guess has to be in between there would be -2. Okay? So I'll use those numbers to find that one. Second, calculate 0. Yeah. Then I type in -3, -1, and -2. Yep, hit enter every time. -2.25? Yep.
So would your answer be -3.6, -2.2, union 2.2, 3.6?
Correct. That's it. How did I get this one? This one down here? This one? I used the numbers -3, -1, and -2. You have to type in, on the left, you have to type in the number that's less than the number on the right. You can't mix them up. I have 2.25. You can practice, and we'll go over it again tomorrow. You typed in the equation? Oh. Yep. Okay. Oh, we got 5 minutes? Ooh, I got one more question to go over. So try some of those. Remember, the left bound has to be on the left side. Right bound on the right side, in the middle has to be the guess. Yeah. Yeah. All right. Only one question on here. This is kind of fun. What do you think the difference is between the graph in number 74, the f function, versus the g function? What's the difference between f and g? The operations are inverse, they're opposite. How's that going to affect the graph? Over the x-axis. So g of x equals negative f of x, which means it's reflected over the x-axis. Now I'm going to show you something to see this on the graph. I'll go over here. Y equals. We do this in calculus quite a bit when we have two equations. 0.25x caret 3 minus 2x plus 1. I'm going to type in the other one. Whoa, there's a lot of extra down there. Delete, 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 delete. There we go. And now I have negative. Don't forget, that's a little one. Negative 0.25x caret 3 plus 2x minus 1. Now, if you have an 82, this doesn't work. On the first one, I took my cursor all the way over to that line. See how it's blinking? I just used my left button arrow and went over there. I'm going to press enter, 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 enter. And I want to bubble with a trace. There. Bubble with a trace. Nice. And then for my second one, I'm going to pick a thick line. I'm going to press enter once. And I like to change it. I like to go to mode. And I like to go to simultaneous instead of sequential, simultaneous. That means they're graphing at the same time at the same instance. The bubbles are nice because if you have an airplane problem, you can actually see that the bubbles will crash on their pass according to time. Where are they at? And it's kind of cool, especially in parametric mode. But anyway, I go to graph, and stop it. Zoom 6. Sorry. So here we go. There's the bubble. Bang. And you can see that they are reflections of each other over the x-axis. You press on. It's a break. So you can see that it's really cool in parametric because you can have like 4 cars going different rates and different paths. And anyway, you get the idea.
That is awesome.
It is. I like it a lot. So, but it is reflected over the x-axis. On the last one I'm going to talk about, what's the difference between 78, G, and F? What's the difference between the two? The plus 2x and the minus 2x. That's going to switch which way the graph moves. And you can graph it out and see that. But for tomorrow on this page, what page is it? 169. Go ahead and do, what did we stop at today? Like 53? 65? Oh, okay. Well, make sure you can do 57 through 77 odd, okay? If you're all the way through 65 or 67, you don't have much to do. Yeah, that was fun. And don't forget, November 2nd. That's an important day. Hour?